Welcome to Wasomi. We are going to look at logarithms, and our subtopic today is index notation versus logarithmic notation. So by the end of the lesson, you should be able to change index notation to logarithmic notation and vice versa. You should also be able to review what you did in Form 1, writing numbers in standard form, and finally be able to read logarithms to base 10 from the logarithm tables. We are going to use an example. Given 3 to power 2 is equals to 9. We have already seen this in our previous lesson. 3 squared is equals to 9. This is what we refer as the index notation. The index notation because we have the number written with a power. We can be able to change this, and the index or the power is what is called the logarithm of the corresponding number to base 3, written as logarithm of 9 to base 3 is equals to 2. So the power is called the logarithm of the corresponding numbers to the same base. I just want you to note that when we were in the index notation, 3 is the base, 2 is the power to give us the solution of 9. When we move on to the logarithmic notation, the base still remains. Our base was 3, our base will still be 3 here. And it becomes the logarithm of the number to the base which was given here as 3, and the power becomes the solution. This is now what we call the logarithmic notation. So you should be able to move from index notation to logarithmic notation and vice versa. We are going to look at two examples to move from either of them. So we can have here index notation vis-a-vis logarithmic notation. And we are still going to use our logarithm to base 3, and we have 3 to power 3. 3 to power 3 is equals to 27. That is the index notation. We have said the power becomes the logarithm and the base remains. So this will be logarithm of 27 to base 3 is equals to 3. Then we are going to have 3 to power 1 is 3. Therefore here we have logarithm of 3 to base 3 is equals to 1. And we start realizing that if you are finding the logarithm of a number to the same base, the answer is 1. We are going to find that as we move ahead. In general, if we have logarithm of n to base n is equals to a. In index notation, we have m. Remember, m is the base. It must also be the base here. And the power is this one. So we have m to power a is equals to n. Is it okay? A should be the power. It is okay. M is the base, the power is equals to n. It is correct. M to power a is equals to n. So we should be able to move either way. Change numbers from index to logarithmic or from logarithmic to index notation. It is going to be very helpful when we are solving questions to do with logarithms and indices. So next, we are going to look at the standard form. We must be able to express numbers in standard form to be able to read common logarithms from the tables. To be able to write a number in standard form, we write the number in the form a times 10 to power n, where a must be a number between 1 and 10, not 10 not included. That is 1 must be less or equal to a less than 10. So 10 not included, we can go up to 9.999. And n is an integer. You did this in Form 1, so you can have a recap of what you did so that you can be able to apply the same knowledge when we are reading logarithms from tables. Just one example, write the following number in standard form, 0.031. We have said our number must be between 1 and 10, 10 not included. Therefore, we are going to bring our decimal point here between 3 and 1. And we have 3.1 times 10 to power negative 2. 3.1 times 10 to power negative 2. With that in mind, we can now be able to read logarithms from our logarithm tables. And I'm hoping you have your logarithm table on page 1. Reading logarithms from tables. We are going to use just 2 examples to illustrate. Read from the tables the logarithm of 2.56. And you can see I've written logarithm to base 10. We call them common logarithms. And those are the logarithms that we are given in our mathematical tables on page 1. Logarithm to base 10. So our step 1 is to write the number in standard form. 2.56 in standard form. Remember, it is 2.56 times 10 to the power 0 because the number is already between 1 and 10. When we multiply by 10 to the power 0, remember in indices we said this is 1. So it's like saying 2.56 times 1. Now, when we are reading logarithm from tables, the power of 10 becomes the whole number part. This one 0, so we come and write it is 0 point. And then we go to our mathematical tables on page 1. We call this the main column and we call this the difference column. And you read from the main column the logarithm of 2.56. 2.56. And you can see it is 0.4065. That makes the decimal part 4065. So the logarithm to base 10 of 2.56 is 0.40. 2.5. That is 2.56. 4082. 4082. This one is very easy because you are not going to the difference column. We can move on to example 2. Find the logarithm of 3.752. I have added one more digit so that we can be able to know how we use the difference column. Step 1, we write the number in standard form. And we get 3.752 times 10 to the power 0. The power of 10 becomes the whole number part, 0 point. Then we go to our mathematical table and we find the logarithm of 3.75. 3.75, we get 0.5740. 0.5740. You realize we have a 2 here. Because the 2 cannot be found in the main column, we move on to the difference column, where we have 3.7 row intersecting with the difference column headed by 2, and where they intersect, you read the number that is there. 3.752, and you will find the number is 2. We always add that 2. You realize the difference column we are told to add. You add it from the right hand side here, from the end here, you add 2, and you get 0.5742. So this one becomes the logarithm of 3.752 is 0.5742. 0.5742. Now this part here, we are getting this from the power of 10. We call it the characteristic. The whole number part, which can be an integer. You remember we say when we are expressing this to power n is an integer. So it can be either negative or positive or 0. So the characteristics is an integer, a negative number, positive or 0. The other part, the decimal part, we call it the mantissa. And under all circumstances, the decimal part, which is the mantissa, must be positive. That is what we are reading from our mathematical tables. It must be positive. So in a situation whereby you read logarithm and you find that the characteristic is negative, we don't write a negative at the front here. We write negative at the top of the characteristic to indicate that it is only the characteristic that is negative, but the mantissa is positive. We can have one last example of such by finding the logarithm of 0.00063. Logarithm to base 10 of that. Our step 1 is to write the number in standard form, and this gives us 6.3 times 10 to the power minus 3. 6.3 times 10 to power minus 4. 6.3 times 10 to power minus 4. We have said this power of 10 is what forms the characteristic. In our situation here, the characteristics is negative 4. We don't write it as negative 4. Actually, we write it as 4 with a bar at the top to indicate that it is only the characteristic that is negative. And then from there, we read from our table the logarithm of 6.3. And when you read the logarithm of 6.3, that one is in page 2, you get 0.7993. 7993. Now this forms the decimal part, which is positive. Therefore, when we have the characteristics as negative, you don't put a negative here, because that means that everything is negative. But actually, we just write a bar there to show that only the characteristic is negative, but the mantissa is positive. I hope we have done well and we have met our objective. I'm going to leave you with an exercise as well. You know, mathematics, practice makes perfect. Find the logarithm of first question 0.57. Find the logarithm of 0.57, and then 2, find the logarithm of 47.9. Thank you very much. Let us meet in the next lesson.